Welcome to The Bee's Knees, a podcast all about native bees. Wild and native bees are under threat worldwide. In each episode, we look at actionable things we can do to support these adorable guys whose pollination work is crucial for maintaining biodiversity. I'm JC Meyer, and I thank you for being here. If bees had grocery bags, do you wonder what might be in them? I'm very curious about optimal ways we can design gardens that actually support bee health. So I was excited to find a study that found wild bumblebees aren't just buzzing around randomly. They're strategic foragers, carefully choosing flowers based on the nutritional content of their pollen, balancing protein, fats, and carbs like tiny dietitians in flight. Dr. Justin Bain's research was done over 8 years in the Colorado Rocky Mountains. He and the team tracked 8 species of bumblebees and mapped out their pollen preferences. Turns out, spring flowers are like protein shakes, while late summer blooms are more like energy bars. So your team found that wild bumblebees aren't just collecting pollen randomly, they're actually balancing protein, fat, and carbs like tiny little nutritionists. What surprised you most about their dietary strategies?
Yeah, that's a great question. Yeah, so what surprised me most about this was the fact that we actually found that this wild bumblebee community partitioned into 2 distinct nutritional niche groups. In our study, we had 8 wild bumblebee species, and we found that half of those species partitioned into a high protein and lower lipid / carbohydrate niche group, whereas the other half were collecting lower to moderate protein and then higher lipid and carbohydrates. And so this was surprising because these bee species are all foraging at the same time. They're foraging in the same meadows. We would likely expect them to be collecting the same pollen or the same pollen nutritional ratios. But in fact, we saw that half these species were collecting high protein and then half of these were collecting low protein. And in comparison to sort of these other studies that have been done on bumblebee nutritional ecology, which have been done primarily in laboratory studies where they've been able to control variables, we actually found that we want to look at what bees are doing in the wild. So what are they doing in their natural habitats? So we lose some of that control where laboratory studies can control a lot of different variables. And we looked at these field studies where bees are foraging naturally. So it was really interesting and surprising to find that these bees are actually doing different things in the wild.
So this is very interesting to me. One of the things that you found was that the bees' tongue length plays a role in which flowers they can actually access, which makes sense if you think about it. Also, you found that it also depends what kind of nutrients they prefer. Can you explain how a bee's physical traits shape its diet?
Yeah. So, like you said, it is sort of intuitive, right? With it allows them to access different flowers. And that's sort of a fundamental area of research in ecology, going back to Darwin and Darwin's finches with different beak shapes, allowing these birds to access different food resources. And it's the same thing with bees. So the tongue lengths, allow them to access flowers that have deeper nectar tubes, right? The interesting thing about these results that we didn't expect to find, or at least weren't necessarily expecting to find, was that tongue lengths appears to be associated with what they're collecting for pollen. We think of tongue length as being a trait that's associated with nectar foraging and nectar collection. But because this matched up with pollen, that's a really interesting story that we don't necessarily have the full answers for yet. But, some hypotheses could be the tongue length is sort of filtering the landscape for them to an extent, right? Nectar foraging is usually considered to be broader, so they'll forage at more plant species for nectar than for pollen. And referring to bumblebees in particular here. But so because they're foraging at more species for nectar, that might automatically shift what they are collecting for pollen. So they're foraging from a narrower subset of plant species for pollen than they are for nectar. And so for the longer tongue bumblebees, right, it might not be necessarily that they prefer high protein pollen, but they prefer the plant species that contain these high protein pollen, which also have the nectar that they're accessing as well, right? It could be a little bit of optimal foraging efficiency going on as well. What's the most efficient thing for them to collect, as well as maybe what they're preferring to collect from a nutritional perspective. I want to also emphasize too that it's not necessarily that high protein is always what we should be focusing our efforts on. I think there's sort of a bias, might be too strong of a word in the literature, but there is sort of an assumption being made that high protein is sort of what is best for all bee species, and especially bumblebee species. And what my paper here shows is actually there are diverse nutritional preferences. Bee species are collecting different types of nutrition, and even if they are extremely closely related. So I did go on a little bit of a tangent there, but I wanted to also get that out.
It's great. It's great. I love tangents. So this study tracked bee diets across 8 years and found seasonal shifts in pollen nutrition. How did the bees adapt their foraging as their colonies grow and their nutritional needs change?
Oh, yeah, that's a great question. So this is another area that was surprising to me. It was surprising in this sense because, again, we found half these bumblebee species, particularly the high protein niche group, they did not shift their foraging across life stages in their colony life cycle. So they were much more specialized. So we can consider that set of bumblebee species to be nutritional specialists. Whether the queen is out foraging in the springtime or the workers are foraging later in the summer, they're largely collecting the same nutritional ratios, right? So they're actively balancing the nutrition they're gathering to hit these ratios from what's available in the landscape. The short-tongued bumblebees, on the other hand, we do see a shift in their foraging strategies across their life cycle. So the queens, which are larger than the workers, they have, longer tongue lengths because they have larger bodies. There's tends to be a correlation between body size and tongue length. They potentially, right, going off this resource access hypothesis, right, the queens might be able to access a broader set of nutrients in the landscape than the workers. So they are more generalized in the nutrients that they're collecting than the workers. There might also be a nutritional hypothesis here as well, which is that when the queens are out foraging in the springtime, this is when they're founding their nests and founding their colonies and laying the first workers. And so they might actively seek out to get higher protein because that higher protein will then produce the most healthy and largest of the workers, which then go out and forage later in the summer. Then it shifts over into the summertime when the workers are out primarily foraging. Those bees might actually be shifting to more of a quantity over quality nutritional strategy where they're going to pick up, the pollen that's the most efficient to collect for them and their specific set of traits and bring that back to their colonies because perhaps that might be sufficient from a nutritional perspective for them. They don't necessarily need to go out and collect the highest protein pollen to produce the same amount of workers and have the same colony success. So these are all possibilities that might be going on. And yeah, it's a really exciting time to be studying
this is so interesting. So how they kind of adapt their foraging habits. Now I want to know if you have thoughts how they will need to continue to adapt based on climate change and habitat loss.
Yeah, that's such an important question. And from a nutritional perspective, the climate change and habitat loss both affect the nutritional landscape that's available for bees. So which is essentially the composition of flowers of plant species that are available, which can also affect the nutritional profiles that are available to the bees in the meadows that they're foraging at, right? So habitat loss often very directly changes the quantity and quality of the flowers in the landscape, changing the nutritional availability. So some bees that, maybe we might predict that nutritional generalist bees might be better adapted to, say, disturbed environments like going on with habitat loss or climate change. They can better adapt to changes in the floral resource landscape, the nutritional landscape. Whereas nutritional specialists, right, perhaps some of these really high protein foragers that do really well in the Colorado Rocky Mountains where there isn't this habitat disturbance, they could be very vulnerable in other locations where there is a loss, habitat changes, climate change is affecting the abundance of different flowers in different ways. So really it depends on where is this bumblebee's nutritional niche? Where is it located within the broader scope of the nutritional landscape? Are they on the edges of the landscape? They could be more vulnerable to these changes. If they're in the center of the landscape, they're kind of collecting the middle of the road, their nutritional niche is sort of in the middle of the road. They very likely could be better able to adapt to these different changes going on.
Yeah, there are so many variables almost, for each
Yeah.
individual little bee. So I'm going to kind of put you on the spot here. Your research kind of suggests we need to think beyond just planting more flowers. In your mind, what does nutritional diversity look like in a bee-friendly landscape?
Yeah, I mean, for sure. This is going to be a growing area of research in terms of conservation and how we might apply these ideas to conservation and restoration. In terms of what does nutritional diversity look like, right? We might think about classic plant diversity, right? Just the number of species in a landscape, in a garden, in a yard. Nutritional diversity goes one step deeper and asks, what is diversity of nutritional profiles? So if we have 10 plant species that are pretty much the same, maybe they're all in the same plant family, right? We're not going to have high nutritional diversity. So we need to also consider the quality of the resources that we're putting out and not just the number of plant species that are available. It might be worth spending a beat on the nutritional landscape itself, which is, functionally the grocery stores for bees, right? Like bumblebees are going out and foraging in meadows, and sort of the default hypothesis is that, it is an optimal foraging task for them when they're out foraging. Like they're choosing the flowers that may be the easiest for them to collect nectar or to collect pollen. But what my paper shows and what a lot of other papers are showing now is that considering this nutritional landscape is extremely valuable and sheds a new dimension or a new light on what bumblebees are actually doing when they're out picking up pollen and nectar from flowers. And so the nutritional landscape, I think, is a very important something very important to consider, both from a conservation restoration perspective, as well as fundamental ecology, pollinator biology, and how we might actually protect individual species and then potentially pollinator communities more broadly. So the nutritional landscape, it's a variable environment. Just even through non-disturbances, normal non-climate change scenarios, the baseline is that it is going to vary through space and time because different habitat characteristics are changing. Phenology is always shifting, different plant species are coming up. And so that's the nutritional landscape is always something that is dynamic and it's not static. And so, yeah, something else my paper found was that the nutritional landscape is shifting from early spring, where we see a lot of higher protein plant species, to the late summer or the early fall, where there's a lot of Asteraceae out, a lot of sunflower species out. These tend to be higher fat and carbohydrates. And these might be tied or, it might be well adapted with the bumblebee. So the bumblebee timing is sort of in sync with the flowering landscape to match up with their life stages, right? So just, these important things to consider and everything else that we also have to consider.
Absolutely. So if you could recommend people do just one thing to support native bees, what would it be?
Yeah, this is such a good question. I wish I could say that, just go to your local native plant guide and look up the nutritional labels for all these different plant species and then base your planting off of that. Unfortunately, that doesn't exist yet. I expect in the next 5 years, we'll have something like that from conversations I've had with other folks in this space. So I think in the meantime, though, obviously it's important to plant your native flowers, plant a diversity of native flowers, but then also make sure you're not leaving any nutritional gaps in the foraging during the foraging period of wild bees. So, you can also think about this more in terms of the life cycle of bees, right? You want to support them at their different life stages, especially the vulnerable life stages. Make sure you're providing a lot of or diversity, a mix of plant species in the springtime when the queens are out foraging and producing their nests. That's a particularly vulnerable period. So I think making sure you have a supply of flowers available to bees at these specific time periods and throughout their life cycle is really key.
From long-tongued bees chasing high-protein pollen to short-tongued bees going for the carb-rich stuff, Justin's research shows that pollinators are anything but one size fits all. As global pollinator populations face threats from habitat loss and climate change, this kind of research helps us rethink conservation, focusing not just on saving bees, but on feeding them well. Thanks to Justin for such an eye-opening discussion, and thank you for listening. If you enjoyed this episode, I'd love it if you shared it with a friend. And be sure to visit the website, where you'll find recommendations for other episodes focused on bee nutrition. Until next time, stay curious.